Chapter 10, demonstration question number 2. If we read this question, we are being asked to find how much money one needs to deposit now in order to have an annuity of $500 at the end of every month from age 60 to 80, in other words for 20 years, if interest rate is 6% compounded semi-annually. So if we examine that, we'll have to figure out what type of annuity we're dealing in here with. So first we see that we got term certain, 20 years from 60 to 80. So that's annuity certain because the term is fixed. Then we're saying that the payments of $500 are going to be at the end of every month. So that's ordinary annuity. And then we're saying that there will be 12 payments per year, but 2 compounding periods per year. So in other words, P over Y is not equal to C over Y. That's going to be general. So ordinary general annuity, the formula for present value is given by this formula, and we have to replace those two i's in here with I sub 2. To help us understand this a little bit better, we want to basically show some diagram, money line. So I prepare in here cash flow diagram. We're extracting all the information that is given to us in here. So first of all, present value, that's the unknown, that's the one we'll have to solve for. And then we're saying the term is equal to number of years from 80 to 60, that's 20 years. N is equal to T times P over Y. T is in years, so 20 times 12 is 240. Nominal rate is given as 6%, so we put 6% in here. Payment is given as $500, so payment is 500. Future value is going to be 0, so this amount is 0. P over Y, 12 payments per year, every month, at the end of every month. So we're going to show in here at the end of every month for the next 240 payments in here. And then C over Y is 2. Because P over Y is not equal to C over Y, we have to use I sub 2. And the only thing that you have to show is calculation for I sub 2. You can use your calculator to evaluate that. And then we're going to be using financial keys. So on the final exam, you might be asked to calculate I sub 2. So let's see how we're going to do that. So we're going to put a left bracket and then 1 plus 0.06 divided by 2, and then right bracket, then yx, then left bracket, 2 divided by 12, right bracket, and then minus 1, and is equal to, and then we're going to store that in memory 2, so we can always recall. I like to use memory 2 so because that's like I sub 2. If you were to use the 8384, and the situation is a little bit easier, you could bracket and then 1 plus 0.06 divided by 2, and then right bracket, then this exponent in here, left bracket, 2 divided by 12, right bracket, and then minus 1 and equal, and then enter, alpha, store, first store, and then alpha x squared, so that's under I, so you can be storing under I, and enter. So if I want to see that in percentages, so the times 100, so that's 0.494 percentages. I can add some extra decimal places, but that's sufficient for us. At this stage, we copy the formula for present value of ordinary general annuity. So this I is going to be replaced with I sub 2. We calculate I sub 2 on the previous slide, and we substitute all these values. So 500 is the payment times the formula. That's your N minus 240 divided by I sub 2. And at this stage, you can use your TI Business Analyst 2 and plug in those values, and we have our answer. So if we were to use the Business Analyst 2, first you always good idea to clear the memory, and then 240, that's your N, 6, that's your I over Y, 0 for present value, negative 500, so 500, change sign, and that's payment, 0 for future value. Then second function, I over Y, and we have 12 payments, so that's correct. Press enter, and then scroll down. C over Y is 2, so we have to override that, and press enter, and then compute present value, and we have the answer the same as they have there. For TI 8384, very similar. We're going to put in here N is equal to 240, 240, I is equal 6, present value is equal 0, payment is equal to minus 500, future value is 0, number of payments per year 12, number of compounding periods per year 2, and then E and D, and then we scroll to present value and press alpha and enter, and we have the same value as before.